presentation mode underneath.
Yeah.
Okay.
Yeah, while you do that, Neil, first let me thank you for being here and all people present as well. So this one is in English because there was a New Year's wish to invite more international speakers for international knowledge exchange. And you were very high on that list, Neil, because we have the same hobby on permeable pavement. And of course, we've seen each other by the International Conference of Urban Drainage in Delft. So I heard your story already. Normally we do a bit of an introduction, but I think we can just dive in. And when we have some questions, I will ask the people to introduce themselves so you know who's there. Yeah, shall we just dive into it? So the floor is yours, Neil. Yeah.
No, thanks a lot. Okay, so I mean, as a bit of an introduction, so I'm a Emeritus Professor now at University of Cape Town. I officially retired just over a year ago, but as I said, not really. And this is, so I'm kind of busy spending a lot of my time tying up some of the loose ends that I had of my various students over the years, which is quite fun in many ways. I get to write all those papers that I should have written a long time ago, at long last. Now, there we go. So the format of presentation, I'm going to chat very briefly about PICP and its failure mechanisms. You probably all know this already, so I probably don't need to dwell on it an awful lot. But what I want to talk about is some of the site investigations we did and the laboratory investigations we did to try and address the big problem we have in South Africa as to why PICP is not working. It is, I regard it as something of an embarrassing failure and as something that is threatening to drag down sustainable drainage systems in general. You know, it's in the end, I decided that if I couldn't stop it, I better figure out how to do it better. And so I'll talk a bit about what we found out in terms of the clogging rate, and of course, PICP fails by blockage. And then right at the end, I'll talk about the guidelines that we put together, which are freely available from a link that I'm sure will be provided to you. Okay, so, right, sorry, the Teams keeps on popping your faces in front of my screen, which is not a smart idea. Maybe I should use the big screen. Hang on, I'm just going to shift this across very slightly so I can get a better view. Oh, no, it's not smash my nice glass of the big screen. Can't see myself. Is this looking okay?
Yeah, it's still okay. Yeah, we're on to
all right.
And maybe Neil, do you want questions afterward, or can people break in? What do you prefer?
You know what? Given the size, given the fact that it's a very small group, I'm quite happy for you to chip in and ask questions as we go along. You know, right. it's not such a big deal whether that I finished all in one go. So anyway, this is an introductory slide. Permeable pavements, as you know, comes in many shapes and sizes. You get some very nice stone pavements like the bottom one, which is actually from the UK. Porous concrete, that was actually in San Francisco, in fact, a while back. Grass blocks, and then the permanent locking concrete pavement on the left-hand side. And just in passing, that was pretty much the view out of my office window when it was completed. Of course, I don't have that office anymore because I'm not head of department anymore. And I only go onto campus when I need to. But that was what it looked like shortly after it was completed, a fairly typical permanent locking concrete. Come on. There we go. All right. Again, you're probably all aware of this. The mechanism is quite simple. You have concrete pavers that are shaped to allow water to permeate around the brick into a series of stone layers and into the sub base or into an under drain from whence it gets taken away. And if it's done properly or brand new, it has an enormous capacity to take away runoff. I mean, we couldn't ever measure the maximum amount. But kind of when we were guessing it might be 40 meters an hour, we knew we were past the realms of measuring anything with any degree of accuracy. I think I'm not sure on this presentation, but I know Ryan Winston from the US has a wonderful picture of a fire engine splashing water on permeable pavement, brand new. And the moral of the story is that you shouldn't ever be able to pond it. It should always just disappear. And along the way, it does quite a reasonable job of taking out a lot of the solids in the stormwater. It does a less good job about taking out things like nutrients, although another study that I did, and if you want to hear that, I'm happy to come back. I did have a student look at the holy grail of can we get denitrification in PICP? And the answer is yes. But the lengths you have to go to achieve this might make it economical. So, but as a nice academic exercise, one nice thing about being a university is you can you can indulge yourself in fantasy type investigations. So, but mostly it sieves out the solids, and the solids, of course, contain a lot of heavy metals and even some nutrients as well. And its main role actually is to reduce immediate runoff and either feed the groundwater or trickle feed back into the stormwater system. And pavers come in many shapes and sizes. And I've shown on the right-hand side kind of 3 of the most commonly used ones in South Africa, but I'm aware there are literally hundreds. And more important, to the left-hand side, something which is that I felt was quite important was to put in some kind of description about these things that might be of use to civil engineers or the science, and that is the joints, those openings that allow the water to pass through the paving layers. And they're called joints, and we have a joint length and a joint width. Of course, it can get very complicated, as you can see in the bottom picture, very difficult to measure those kind of openings. But we did need to know something about the opening area. And in our later research, we worked quite a lot with opening area as a way of understanding performance. In other words, do larger openings make for better performance, essentially? All right, so some examples of PICP in South Africa. This is the first one that went into Cape Town in 2009, just ready for the World Cup football that some of you might remember. So it was quite annoying. They put this thing down, and the next thing they did is they came along with a whole lot of marquees and hammered nails into the brand new bricks, which goes to show that, well, some people don't care. So that's been around for a while. And here is some more under construction. This is in Joburg. That's in Johannesburg. You can see the different pavers there. And here's another one. This is back in Cape Town, showing some rudimentary maintenance. And I'm going to talk a little bit about maintenance as well. But let's move on. So the problem comes right here. So I've been trying to promote sustainable drainage systems in South Africa since about 2007, 2008 or so. I got on funding from the Water Research Commission to basically write guidelines for an alternative way of doing stormwater that would be more environmentally friendly. I had lots of friends around the world who were into this in a big way, so I could lean on them. And we produced guidelines, but PICP was one of 12 different main approaches that was identified by actually one of my students. He used to call them the 12 apostles. And PICP was one of them, or permeable pavements was one of them. And at the time, I thought, yeah, well, that's nice, but it would be totally useless in South Africa. You can see how it would fail very quickly. Maybe just to mention why that is the case. And that is simply because if you've been to South Africa, particularly at this time of the year. Today was over 30 degrees. It was as dry as a bone. We've had a howling gale going for the last couple of days. It's hot, dry, dusty, and throw in poorer construction, no maintenance. You can understand why PICP would fail in droves, and it does. So I had lots of students run around the country documenting PICP installations, particularly the older ones, but even the newer ones. And this was about 4 or 5 years ago. We struggled to find any that was still functioning as designed. So going back to my original feeling that permeable pavement is not appropriate in a country like South Africa. Might be appropriate in Germany or Britain or the Netherlands or all of these, but in South Africa, our climate, our level of development, the management, whatever, is not conducive to its work, but it's very popular. And the reason why it's very popular is because the more progressive cities, the metros. Now, South Africa, it's a big country, about 64 million people, but a huge proportion of the population lives in these big metros, big sprawling cities like Cape Town, 5 million, Johannesburg, 6 or 7 million, Tshwane is about 3 million, eThekwini is about 4 million, and then lots of people living in these areas. And progressive metros were insisting on SUDs. No one knew how to do it. No one had it, the consultants weren't prepared to go and read it up or even follow the links provided. They got sold very quickly in PICP because it doesn't take any space. That's the reason I've heard every time. It doesn't take any space. Bioretention of cells, way better. You can pop them just about everywhere. Tree pits, you can see that top right corner. That could have been a very successful tree pit. Didn't even cross their minds. PICP doesn't take any space. The developers don't want to give up any space. So we put them in. We get our tick from the municipality. We get paid. We move on. And a month later, and I kid you not, a month later, it's failed and nobody cares. Well, somebody cares. I mean, I obviously cared. And there were a couple of others too. And there were many reasons for it. I mean, you can see, for example, the top left-hand side. I don't know whether you can see my cursor at all. I'm not sure what comes through. But the top left-hand side is a roundabout. Don't put PICP in a roundabout unless you got it very well restrained, because the turning motion of vehicles will force the blocks apart. They put it below an embankment that was inadequately stabilized and had no filter. That's the top middle. So the sand, first rainfall, this in Johannesburg, they get these big downpours and thunderstorms, just simply took all the sand, some of it actually just put there by the landscapers and deposited on the paving. I got to see this paving. It was the oldest, probably the oldest installation in South Africa. It was in Witwatersrand, University of Witwatersrand, finished in about 2008. I was taken to it a week after it was finished, and you could already see it starting to fail. In the top right, you can see the failure of the restraints. They're all cracking open. You can see trees dropping leaves, and so on and so on. I mean, wherever you look, there is failure, failure, failure. And I got to be exceptionally worried that this was giving SUDs a bad reputation. Okay, so what were the primary failure mechanisms that we identified? Well, most of them are obvious. I would have thought every engineer would have thought this without even a blink. It was the wind-blown dust, the high run-on. I mean, some of these you connect large sites to them, making sure that all the sand and muck from the surrounding areas in South Africa can get very mucky, let me tell you. We have informal settlements, we have poor refuse collection. We have everything. High run-on of sediment-laid stormwater, poor construction practices. I mean, the joint filling material is supposed to be a 2 to 3 millimeter grit. I mean, some people were putting builder's sand in here and wondering why the thing had failed on day one. There were dirty aggregates. I mean, in some places they had put stone in there and they hadn't, it's supposed to be a single size aggregate. And they had put aggregate, but I mean, it was like a concrete mix. It had everything in it. There was no, it was not single size at all. There was dirt in it, inadequate edge restraints, et al. Differential settlement was, we saw on many occasions, and you see that when you get the whole floor, the whole surface starts to wave as it sort of because of vehicle loadings. Unsuitable environmental conditions. These things were put under trees or next to planters, or I mean, the one very common one is in South Africa, because its climate is very similar to Australia. The Australian vegetation grows very well. In fact, Australian vegetation grows better in South Africa than South African vegetation. And the reason for that is quite simple, because the normal controls have been removed. It works in reverse too. South African vegetation goes better in Australia than Australian vegetation because the natural controls have been removed. So we have these big eucalypt trees. They go to massive, 20, 30 meters high, dropping this fine pollen onto the pavers and plugging the gaps. Lack of maintenance. Well, very few sites are maintained at all. When we did our, at the time we did our survey, it might have changed now, but I wouldn't hold my breath. There was zero maintenance in Johannesburg. In Cape Town, we knew of only, I think, one site really, but there might have been a couple I didn't know of, that was being maintained regularly and was actually making out okay because of it. And I mean, part is because of a culture of lack of maintenance, part is because we don't have the equipment. I mean, I went to the US on a sort of interesting tour. I spent a bit of time and at the Bull Hunt in North NC State, if you know him. And then I was up at the LID, the Operations and Maintenance Conference, and they had demos of how you do maintenance at PICP with all this fancy machinery. And of course, we're not going to get that in a country like South Africa. You're going to have to look to something else. So I get it as difficult, but it's not impossible. So, I mean, one concludes that in South Africa, at any rate, although it was quite interesting chatting to people around the world who are doing PICP research, there's a lot of disagreement, but essentially poor understanding of PICP design, construction, and maintenance. And we needed to do better. And my tactic in the end was to get some funding to do a proper investigation and come up not only with a report of why things were failing, but guidelines to stop the rot, to try and guide consultants and municipal managers and contractors to try and do a better job.
Yeah. And maybe one question, Neil, because you talk about maintenance. There was only one site or several sites in Cape Town. You don't have the machinery. What do you mean with maintenance? What kind of maintenance did they do? Was that sweeping? Was it more? What action?
Yeah, so of course there's many ways you can do maintenance, but the sweeping, of course, usually, if you're not careful, actually makes matters worse because you simply sweep dust into the cracks. In theory, vacuuming the stuff out of the cracks should work, but it doesn't. And it doesn't for various reasons. I mean, I say it doesn't. Okay, so I've seen American equipment that claims to do it, but I've seen research that says that it doesn't do a particularly good job. So in the end, and maybe I'll talk about maintenance better on, but essentially what you do with PICP is that you blow out the muck, which is usually situated in the top 20 to 25 millimeters.
Yeah.
And then you sweep it away.
Okay.
And you do that in the one site that is being maintained well. And that's, in fact, you saw that photograph earlier on. Maybe I can go back to that very quickly. Let me see. Oh no, there it is. There it is. That one. Okay, so you can see this is the one site that is being maintained and holding up quite well. It's just down there. It's a shopping center just down the road from me. And what you can see there is a chap there blowing compressed air into the gaps.
Yeah.
Now, of course, South Africa we've got a massive unemployment issue, between 30 and 40% unemployment, which means that people will work for an unbelievably low wages, something that would be regarded as slavery in the Netherlands. Nevertheless, is a job for people. So this is in fact a group of this maintenance crew was put together from unemployed young adults in Cape Town, and essentially it's a compressor, a wand directing a jet of air between the joints and going around each and every brick individually. I mean, it's impressive stuff from a perspective of a rich country. I mean, that's why the Americans have fancy machinery, but we have people.
Yeah.
And so we do that, and you can see even from that slide, he blows the sort of crud out, the top 25 millimeters onto the surface, and you can see it just beyond him. And then someone comes and sweeps it up, and hopefully not too much of it falls back in the gap. And they do that on a 3-yearly cycle.
Yeah,
So,
I was wondering, I have a question, Neil. Hi, Sydney Stacks. I'm from the municipality of Nijmegen, been a water advisor for over 7 years now. It was actually one of my first jobs for the municipality to clean one of the permeable pavements. And we did it with high pressure water. With good results on some places, but less results on other places. And in the end, we just removed all the grit, the aggregate, and basically put the stones back and filled it up again. That was the most effective way. But what I was wondering, because I did some research on that then, from what is the infiltration capacity before and after, and we came to a 5-year cycle. So I was wondering, what are the effects, the percentages of success, and is it varying with this kind of technology? Yeah,
I mean, it is. I mean, I'll show you a couple of results later on, but yeah, it does. Look, I mean, it's water. I know they have tried various places, and some people have reported success. I think here you're more likely to create a slurry in the bottom of your joints. So I side away from water, but air works quite well. And I know in the States there's some machinery that does by machine what we do by hand, also with relatively good things. And the bottom line to understand is what I call kind of there's this kind of 3 different levels of maintenance. Now I've kind of gone blank on what I call them. I think there's sort of there's a sort of light maintenance where you just clean up the road and make sure that the bricks are not chipped and broken and all the rest of it. Then there's a sort of more medium type maintenance where you're coming and doing this kind of effort and blowing the stuff away, and then of course you must refill with chip. And of course that's something a lot of people don't do. They put in chip on day 1, and then it's settled by the first month, and no one even bothers to top it up. Of course, that straight away is a failure mechanism. But these people do. They take the old chip, by the way, and they sieve it and they wash it and they put it back in with a bit of extra just to top up. And this it doesn't restore to new. I mean, I guess we all guess that, because there's always a certain amount of material falls through to the bottom of the joints. But what it does is it kind of gives you about 100% boost on what you got to at the time of maintenance. So if it started off at 20,000 millimeters per hour, it's dropped down to maybe 500 millimeters per hour. You know, you do it and give blow, it goes up to 1,000 millimeters per hour. You know, you come back in 3 years' time and it's down to 250, and you blow it and it goes up to 500. You come back in 3 years' time and it's, you know, you kind of get it. So, I mean, the impression that it's quite obvious that in a well-maintained and well-designed PICP like this one on the right-hand side, which is arguably the most successful in South Africa, it's probably got a realistic life of about 12 to 15 years before we have to do exactly what you suggested: pull up the bricks, take away the bedding stone. In this case, it has a geotextile underneath the bedding zone, and that's another subject of investigation. I mean, because a lot of people don't believe in this. I know the Americans are now set against it. The Australians have now moved against it. My British colleagues are great fans of it, though. We wanted to figure out what we thought of it. In the end, my cautious recommendation is that it is actually a good idea, because it makes that 10-year maintenance reconstruction so much easier, because you can peel off the dirty stone, and you've got clean aggregate underneath that doesn't need any further treatment. But bottom line is that you have to reconstruct these pavements from time to time. And the trick is, of course, it's better 20 years than 2, you know, that kind of thing. And what makes it 20 years rather than 2 or 2 months even is, of course, these other things like keeping sand sources away, keeping deciduous trees away, trees that drop a lot of pollen, you know, planters that aren't well, all of these things, stopping the runoff factor. I mean, this is ideal in the sense that there's pretty much no run-on factor. So it only has to cope with what rain lands on it. It's not trying to cope with the surrounding areas. I mean, they're well-documented instances. One in the States, actually, in Ohio, when they had a run-on factor of something like 110 to 1. I mean, that's instant failure, really. And there's been a lot of work done on that. So this is what I mean by maintenance. It is,
Yeah.
You know, the sort of medium, the regular maintenance every 3 years. Come and blow the muck out, refill with stone, and you're good to go for another 3 years. But after 3 cycles or so, you're going to have to lift all those bricks out, lift the dirty bedding out. If you've got a geotextile underneath, you're probably going to peel off that geotextile and chuck it away and put a fresh one and then relay. But yeah, we haven't got there on this particular site. We will shortly.
Yeah. No, it's good to be clear what kind of maintenance. So we know because you didn't have the equipment, but yeah, this is clear. So blowing with wind, yeah, with air, yeah, perfect.
I mean, the other things, we just don't have the equipment, but fortunately we've got people. So okay, so the research kind of culmination was these 2 years that went into producing this report on clogging failure in South Africa, plus the guidelines. We did extensive literature review, as we always do, of course. We collected data from 11 existing sites, and I'll show you a bit about that, because we really did I had a brilliant student who was in charge of this, and he did things that most normal people would not contemplate in their worst nightmares. Laboratory investigations we did as well to try and get a feeling, you know, in a controlled environment what's going on. And then this working group, and I basically threw it open to anyone in South Africa who had an opinion or wanted to have an opinion. So I got municipal engineers, I got consultants, I got suppliers, both of the pavers, we couldn't get the stone in the end, but the other people spoke up for them. You know, everybody that said, I'm an expert in this, or I want to be an expert in this, I said, come and join. I mean, as you can note from the dates, it was during COVID, and it turned out to be a brilliant thing to do in COVID, because we were all sitting on Zoom anyway. So You know, we could do it from wherever we were. So it was across the country. And I exploited my contacts, and I invited the three sort of key proponents of PICP, who pals of mine, basically. So it was old Ryan, gone blank from Winston from he's now Ohio State. It was Sir Charlesworth from Coventry, and I invited what's his name, from Australia. He declined. He decided he retired. So, but in any case, it was very useful having Sue and Ryan, in part because they had diametrically opposite views. You know, they couldn't agree on anything. So that was nice. So no chances of getting misled because of one person's prejudices. I had everybody's prejudices all mixed in. So it gave us a good chance to really interrogate this. And we had a weekly Zoom sessions where we kind of argued it out. And I had these students presenting what they were finding in the field, which was fantastic because we were able to produce evidence from the field as well as obviously in the laboratory. So, okay, let's start with the field stuff. So the field stuff, this is watch time, huh? I mean, okay, so two main areas up near Johannesburg and then Cape Town. So the two biggest population areas, and basically almost the only places where PICP has been done. I specifically went out and recruited sites that have been around for a long time. Now PICP has only been around for, well, at this stage, the oldest site was the Wits Parkie area. You saw that in one of the slides where the sediment all over. That was then 13 years old. Now it's about 15 years old. And we tried to look for old sites. We tried to look for a range of different approaches, and also sites, of course, where they were willing for us to come and work, of course, and do things. And I mean, you'll see the maintenance trial and diagnostic assessment. What we particularly want, diagnostic assessment, because that means digging it up. And of course, not too many owners of PICP were happy for us to go and dig up their paving, shopping centre. Let's just dig up the middle of your shopping centre. You don't mind, do you? No, of course, go ahead. All right, so how do we test it? So we used a modified ASTM, that's a single ring infiltrometer. On the left-hand side is how you see it in the textbooks. We had one of those. It was really awful because trying to get that putty in, and it doesn't do a particularly good job, and you can't get the markings off. So I decided, no, we're going to reinvent this. So we got a 315 UPVC pipe. We chopped a length off it. We put a neoprene pad at the bottom and in a couple of weights to hold it down. Tried to plug the corners as best we could with some neoprene strips. And we did a lot of tests, and we've been doing the test for some years now to try and get some sort of calibration. And we measured the infiltration rate. But we also did a modified Swift test. This was developed in Australia and is a quick and easy way of determining how blocked your PICP is by just basically looking at the area weighted when you drop 6 liters on it. But I'm not going to talk about that much other than say that we did this as well. So what I want to really do is show you kind of what we were doing now. So this site on the top left-hand side is actually the parade in Cape Town. It's the oldest site in Cape Town. That was the one that was completed in 2009, just ahead of the World Cup. And you can see the test spots. We looked at various spots, trying to find kind of a range of this. On the left, the green was is used extensively for these what they call hawkers stalls. Poor people set up their tables and they sell cooked chickens and chips and things, very greasy stuff. In other words, huge, not very friendly to PICP. And then there were other areas, they were different. And you can see the kind of results that we were getting on the left-hand side. And this is the surface infiltration rates. And you can actually see, to all intents and purposes, they were all blocked. Now, don't be misled. Just because it says it's 30 millimeters per hour does not mean to say it's 30 millimeters per hour, because it's almost impossible to stop leakage out the side, right? So, in fact, once you get below about 250 millimeters per hour, you're really in clogged territory. So this is clogged. You can see that's all clogged, not working. It's a figment of the imagination. And then we lifted the surface pavers, and we looked at the bedding, and we looked at there was a geotextile underneath, and straight away you saw this pattern. I'll show you a bit more of it later on as the muck gets down onto the geotextile and plugs the bottom of the gap. When you remove that, or even you don't even have to remove it, you just need to remove the pavers, you suddenly go from 30 millimeters per hour to maybe even 3,000 millimeters per hour. The geotextile is not blocked generally. There were exceptions. So in the some of them you could see were blocked, and you could see that sediment had been ground into it, we think by vehicle action. So you get water and fine material goes down through the joints, the action of vehicles over it kind of spreads it out like a paste, and it's like a clay layer on top of your geotextile. Plugged. Okay, fine. Let's go further. Cut out a circle. Wow. And look what we have top right. That should not have been the case. This is supposed to be a uniform size aggregate, and you can see it looks like a concrete mix. This clearly is a construction failure. What on earth was the resident engineer doing? I don't know. Maybe they couldn't afford a resident engineer. It cost us everything in this part of the world. But you know, this is the kind of things we were finding. Anyway, we did lots of these tests all over South Africa. Surface tests, down onto the geotextile underneath, on the bedding layer, under the bedding layer, through the bedding layer, all the way down. And we found that there are 4 quite clearly defined failure mechanisms, other than maybe 3, because 3 obviously requires you, well, 2 and 3 both require you to have a geotextile. If you have a geotextile, there are 4 quite clearly defined failure mechanisms. There's the muck in the gap. There's the muck at the bottom of the joints. There's a textile failure because of the mud being ground into it. And then very rarely there's total failure of the aggregate. Of course, if you don't have a geotextile, then in theory, you can eventually get like that over a long period of time. But I don't think it's, you know, it'd have to be a very long period of time, I imagine, to get like that. So that's really a construction failure. So, and I define these as type 1, type 2, type 3, and type 4, because it helps you to understand what the mechanisms are and therefore what you need to do about it, right? So, okay. And then we talked about the maintenance, and the maintenance is really designed to clean up type 1. And it does so partially, but at the expense of moving some of the material into ultimately a type 2 failure. And when you get that type 2 failure, or even type 3 for that matter, you eventually get to a point where the only way out is to lift the bricks, peel off the bedding stone with its geotextile, and then put fresh, right? This is reconstruction. Type 4 is reconstruction all the way through. Okay, so maintenance, that's what's happening on site. But meantime, we've got parallel investigations in the laboratory, 4 HTP test cells to look at, and we had a whole lot of questions. And it was about the geotextiles. Ryan says never use geotextiles. Sue says always use geotextiles. The Australians couldn't make up their mind, eventually settled on never use geotextiles. So what is the link between geotextiles and different types of geotextiles and clogging? I mean, Sue is saying you must use Embertex. The locals are saying it's too expensive. Can we use an alternative? Why can't we just use a non-woven needle punch cheap stuff? Won't it do the same job? No one knows. Okay, so let's try. the link between paver opening and clogging, because different designs have different paver openings, using the same geotextile, changing one thing at a time. The link between different geotextiles and clogging without the pavers installed. Maybe it's not about the pavers. And here's our experimental apparatus. You can see these bins, these jumbo bins. We had some holes drilled in the bottom, and we constructed typical PICP sections in them, with and without geotextiles. You know, it's kind of, you can see we try to replicate in the laboratory what we had in the field. And then we looked at different types of paving design and 3 different types of geotextiles to represent woven, punched, non-woven, heat sealed, non-woven, needle punched, and woven, basically. And we tried lots of combinations. Because of the size, we looked deliberately. In fact, we took from site initially. We took sediment from site that we took from the maintenance. Okay, they cleaned out a site. This is the stuff that clogged, right? So I'm not going to worry about the stuff that doesn't clog. This is the stuff that clogged. We put it through some sieves. We sprinkled it all over as best as we could, and then we applied a rainfall measured in a watering can with no fancy watering device. This is far more accurate, and you know what? I'm convinced it does a better job. And we even tried to simulate vehicles. That was a bit awkward because obviously we can't get a rolling vehicle on this. Sue did offer their very sophisticated full-scale dynamic test platform in the UK. I hesitate at what expense, but anyway, we didn't take her up. And here are the laboratory tests. And so it's infiltration rate against cumulative loading for loads of different tests. And so without going into the details, what's your first impression of these results?
That's a question to us, right?
Yeah. As scientists, what do you think?
Yeah. Well, the lines go down, so but
lines will go down.
Yeah.
And they go down in some sort of curve, yes.
Yeah.
And where do they end up?
Zero, almost zero.
All at the same point. You can see that actually it doesn't seem to matter. All the different things, the combinations. Yes, you can start off with much higher flow rates. You know, over 16,000 millimeters per hour, if you can actually measure that, down to 8,000 millimeters per hour. These are all brand new, just completed, constructed, whatever. They all decay at slightly different rates, but it isn't long before they're pretty much all converged.
Yeah.
You can help think yourself a little bit, but as I'll talk now. So what we did find, what are the factors ultimately aging clogging rate? And this is a combination now of laboratory and site. Loads of experiments on site, loads of experiments in the laboratory, whatever, loads of pondering. Obviously, age of pavement is an issue, but it has links to the environment, installation, and maintenance. What we found out, which rather surprised us, and we got a lot of blowback from this, age doesn't correlate particularly well with blockage. It doesn't. A well-designed, well-maintained pavement can last decades. Yeah. A poorly maintained, poorly designed pavement can fail in minutes. Age is not a particularly good predictor of clogging. Run-on factor. Now, this was a big thing around Winston. He's got a paper on this, and you know he spent a lot of time going around the world saying how, you know, the bigger the runoff factor, the faster you fail because it brings muck onto your pavement. Does it make a difference? Yeah, I guess so. But you know what? It isn't a big correlation either. So yeah, think about it, but don't lose too much sleep. Pavement type, well, the larger joints do better. And they do better simply because they can store more muck until they clog. That's why they do better. I mean, it's not rocket science we're talking about here. Now we come into the zone, that upper geotextile under the paving layer. Americans are adamant it's a bad thing. What we discovered, and I think we did it fairly thoroughly, that actually it's not a problem. And it's not a problem because the clogging happens generally higher up. So it's not in the geotextile. It's in the joints, or it's on the bedding layer. And when we saw a geotextile failure, it was always associated with movement of the bricks over the bedding. If you let your pavers slide like at that turning circle, you are going to have a geotextile failure. But it is not because the geotextile is inherently a bad thing. It's because you haven't constructed the thing properly. Right? You construct, every time where we had well-constructed pavements, well-restrained, no sensible movement, there was never any clogging of the geotextile. Never. And it doesn't really matter what geotextile you use either. Now, in the UK, they like using Imitec because it's got a breakthrough head of about 50 millimeters, and they're trying to create this anaerobic zone and trying to get nutrient removal. Yeah, look, I mean, we've, as I said, my other study, we did a lot of work on this. Good luck to them. You know, in South Africa, it's not the place to do this kind of stuff. Just put the cheapest, a cheap, robust bitumen, we call it, or K-Tech, in there. It'll do the job just as well. In fact, a non-woven needle punched has got more resilience than the rest and is likely to last longer. So which are the big issues? So here are the red ticket items, the ones that you must get right. First is your environment. You've got to, as far as you can reasonably do so, reduce the dust, leaf, and pollen threat. However you do it, you put a filter strip, or you don't put trees anywhere near your pavers, or you know, whatever it takes. Well, you're lucky in the Netherlands because you've got a damp climate, so you don't get a lot of dust. But if you're in South Africa, where we get loads of dust, this is major. You've got to get your environment right. The next red letter item, well, is the design and construction, isn't it? If you don't design and build the thing properly, it's destined to fail. I mean, that's obvious. I mean, this PICP laid flat. I mean, it's quite interesting. I had a phone call from a former classmate of mine, other part of the country, saying there's this major, big, expensive PICP's just failed. The whole, you know, why? This thing was laid on about a 5-degree slope, a big, long PICP, a 5-degree slope. So, okay, this is not rocket science. Water goes into the bedding layer, runs along the top of the subgrade until what happens? It gets to the bottom, pops up, and in true stormwater fashion, pops out all the bricks. A multi-million rand, million euro catastrophe, because the designer didn't understand that PICP should be laid as flat as possible. There are ways of tolerating small slopes and all the rest of it, but do yourself a favor, lay it flat. Ensuring robust edge constraints, I mean, that was very common. Edge constraints kicking out, and then the bricks to start to march away from each other. And then don't use in high traffic intersections. And then, of course, the third red ticket item is maintenance. Keep the surface clean. Replace the gritstone. And of course, preferably blow out the muck from time to time to give it a new lease in life. So, you know, we started off thinking that 1, 2, certainly 1, 2, and 4 were going to be major players, and actually no correlation. They
Yeah.
were outweighed by 5, 6, and 7. Completely outweighed.
Yeah.
If you can't get 5, 6, and 7, don't even worry about the rest. So, okay,
Yeah.
that's what we found. And I might as well finish up and then we can have a bit of a chat. So it went into 2 Water Search Commission documents, freely downloadable. There's the URL. I'm happy to send you the PDF and you can download it to your like. And the first one is about clogging and permeable interlocking concrete pavement. So you can look at the data, you know, all the stuff we did, the data we collected, all the curves, all the stuff. Do what you like. It's kind of the thing that, you know, you give to your PhD student and I mean, I think it's quite well written, but then I'm biased. Most people won't read it. And then the guidelines, which I try to get down to just, I think it's 15 kind of spaced pages, lots of pictures and diagrams, I was tempted to call it, but I decided against it. I was going to, you know, put PICP design for dummies.
Yeah.
Yeah. I think this is a better title. Yeah.
Because, you know, PICP is not difficult to design and instruct. Of course, the devil is in the details. You've got to get the details right. And I must confess, I lean very heavily on the ASCE guidelines for PICP. It is, there's only 2 that I know of, the American one and the British one, and the American one is streets better than the British one, even though the Americans unfortunately have yet to join the 21st century with their units. But they are busy updating it. That's going to come out soon. And by the way, Ryan Winston is the deputy chair of the committee that's updating the ASC. So I mean, straight away I knew several of the committee on the ASC standards, and I just simply referenced them and ICPI as well as the trade in organization of the states. So you know, you can, for the detail of how do you model it, these flows, and how do you work out, you know, what thickness of aggregate you need and all the rest of it. I just said, you know, go and consult this or go and use these programs. There are 2 main computer programs out that do all of this for you, an Australian one and an American one. You know, help yourself. Here are the links. I'm not gonna rehash this, but what I was trying to get at was a kind of a simple dot to dot. Do this, do this, do this, do that, and if you follow these steps, I can guarantee that you'll have better success than 99% of current installations, which I know have failed.
No, you certainly give some very good tips, and yeah, we will share these links as well to everyone. I think it's a very clear story, and good that you also use the international, like Ryan, and probably Australia. The name you forgot was Terry Luke.
Well,
Simon Beecham.
Simon Beecham was the name I forgot.
Yeah.
Simon Beecham is an old friend of mine from when I first became an academic, but then he became vice chancellor. I think it's you know, the problem with vice chancellors is they lose interest in academics, and so now he's retired. I was quite irritated because I thought he would help me, but he didn't. Terry has helped me a little bit as well, but yeah, look, I've been to Australia many times. I know the guys there quite well. So yeah, I had lots of access to their stuff as well. But you know what? We looked all over the world. I mean, we really did. I mean, I even took some surreptitious photographs around the Netherlands because until recently I was in and out of the Netherlands every year, as you probably remember. I was teaching at IHE to see whether you guys could actually give me any tips, but this is where I ended up.
Yeah, well, the results are quite similar. So maybe we still have a couple of minutes. Maybe open the floor if there are any questions. That would be nice. I know for sure Wim is, of course, working on permeable pavement. So that would be nice to have some feedback as well. Maybe before we start questions, I mean, so what is your guess? How many permeable pavements would there be in Cape Town, for example?
It's hard to say because Cape Town's kind of followed a different trajectory. And I think Cape Town was much earlier into SUDS than Johannesburg, and of course, I'd like to think that my proximity to the municipality means that they were scared of me complaining. So there are a lot few. I would guess probably 30 or 40 sites maximum.
Okay.
Yeah. Whereas Johannesburg, I'm sure is into the hundreds.
Yeah. And that's from 2009, you said, right? Was the first around that date? Okay.
Yeah.
Yeah. It's from the Dutch side, it's just before 2000, first pilots came up, and but very similar results. Also about because we don't have dust, but there were some locations, for example, at the beach side, very fine fragments that tend to clog very easily. So most of the recommendations you give would apply for the Netherlands as well. Yeah. And still age seems to be a factor, but it's also because of a lot of sediment in those years get in. So that so not certainly the age, but sometimes about the sediment. Yeah. Are there any?
The one thing that really impressed me about the Netherlands goes back to, I think, Cindy's comment, is that I once, it was in Delft now, I saw a crew in the morning on my way to IHE, and they were busy demolishing a pavement with a two-man crew with a little crane. And when I came back in the afternoon, they were reconstructing. I was very impressed. That's the way you do maintenance if all else fails. You know, just simply reconstruct the thing.
Yeah, exactly. Are there any questions for Neil?
Yeah, I have a question. Can I quickly pop in? Sorry. Hi, Professor. I'm Shanae Taron. I recently also visited Cape Town, just visiting home a bit, and I was quite surprised by all the developments since I've been gone. But especially in the Somerset West, Heidelberg, even Durbanville area, there's a lot of permeable pavements that I've noticed, mostly with the bigger gaps that can also facilitate some vegetation growing in it. But I was wondering, in terms of movement, and you were mentioning like heavy vehicles or heavy traffic, would it not be a better option to then incorporate like permeable asphalt in those kind of areas?
Okay, look, I haven't seen it in Somerset West, but then I haven't been looking in the right place. Bear in mind that I finished the study and I moved on somewhere else. But look, it's quite likely. Johannesburg is moving to Cape Town, bringing all their bad habits with them. So, and we can see it. The Johannesburg gated village is now popping up like mushrooms all over the place. We're working with Baldwin, which is a company that does a lot of these things. And they say they outsell, Cape Town outsells the rest of the country like 2 to 1. They can't build fast enough. Baldwin, they don't do permeable pavements though. They're far smarter. And I'll be working with them. But yeah, I'm quite sure. Other developers not. And then the other question, the comment was about the
permeable asphalt would be a better option.
My goodness. I tremble as to what might happen then. I know it's used once. It was used on the R300 connecting the N1 and N2 in Cape Town. And it was done as an anti-skid. So it's a major freeway, 3-lane freeway each way. It's done as an anti-skid. When we tested it, I wasn't testing it for its permeability. I was looking for the heavy metal loading coming from a brand new freeway to make the point to SANROL, the South African National Road Agency Limited, that their roads are putting heavy metals into the environment, and they have to design for it. But they were using asphalt. I personally, my view is I would not use permeable anything if I could possibly help it, because I don't believe that it's easy in a South African environment to keep it operational in any for a long period, unless you have a very controlled environment like the Blue Route. That's the one site that's done very well. The Blue Route is still going. Virtually everything else has failed. The one outside my old office and UCT is still working, hasn't been maintained except where, of course, where we were doing our testing. And it's kind of holding up, but it's on its way out. I mean, my view is that usually by clever use of your landscaping, you can actually solve most of your problems with your bioretention cells. Basically make sure your planters are below road level, not above. I mean, all over Cape Town, and I've seen it all over the world as well. We've got our road engineers are mad. They want to put flowers on a mountain and then wonder why the water doesn't get there, and then irrigate it because they need to keep their flowers going, the trees growing, instead of dropping it and putting the water in there. I mean, there's been a lot of work done in France at the last ICUD. Flores, you might remember this, a French investigator showing how much water you can put into these tree pits. I mean, there are many, many smarter, better, more reliable, failure-safe ways of doing it than paving, unless, of course, you are forced because you've got to work between two buildings and there's nowhere to go. I mean, there are places where it is an appropriate use, but in my view, most of the uses I've seen are because of the engineers did what the first thing that came into their heads. They simply, it doesn't take any space, so we're going to use it. I mean, I run an exercise. I just did one at Stellenbosch University a couple of months back, and we redesigned Stellenbosch campus to part of your Stellenbosch campus to show you there are many other things you can do. It doesn't have to be about PICP, but yeah, you're going to use it. I would not use, of course, asphalt. By the way, there is a very thriving grass block industry in South Africa. And I've worked quite a bit with them. They're called Terraforce. And it's got its limitations. And the problem is our climate. The Mediterranean climate tends to hammer grass blocks because we get these long, hot, dry summers. I mean, as I'm talking to you, I'm looking at my screen. It's now 6:30 in the evening, and the outside temperature is 33 degrees, right? And we're in a dry season. We don't have much rain for about 4 months. Most of our rain comes in 4 months. So you can imagine what happens to grass and the grass blocks in that kind of environment. Grass blocks doesn't go very well. But having said that, I have had students working with grass blocks in the wetter parts of the country, particularly, and they do work. They're not nearly as effective in terms of the infiltration rates. The infiltration rates are quite slow. Yeah. So you're not going to get the kind of the 8,000 millimeters per hour. You might get 100 millimeters per hour, 50 millimeters per hour. But here's the interesting thing, is that you seldom find one that's blocked, unless, of course, the grass has died. And the reason for that is because the vegetation forms macropores through the surface. So it basically ensures that there's a sieve through the surface layer. So, grass blocks in appropriate places work really well. And the one I showed, I think right at the beginning, I showed you a site of grass blocks right at the beginning. I think it was the second one. That's up in the mist belt in Hillcrest above Durban, where it kind of rains all the time, real European type climate, works beautifully.
Nice. Yeah.
I also have a question. It's actually related because Charnay asked about permeable asphalt. I also did some tests in my municipality, just with a few locations, so no statistical significance or anything. But we tried to clean the porous. No, not asphalt, but porous bricks.
Okay.
That we had, and we had an effect of around 90% back to the original infiltration rate. But it was with what you were talking about that you don't have with this high tech. Well, we call it in the Netherlands a ZOAP cleaner. Not sure if if you know, but it's a vacuum cleaner. It has actually quite a big effect on 2 of the 3 locations that we discovered. But I was wondering, did you do any research on those kind of porous bricks to compare as well? No, because I heard you talk about the green blocks, and they had a lower infiltration rate, which is also the case with the porous blocks, but they're cheaper to clean. So now we have a discussion in my municipality. Yeah, you have this high infiltration rate, but high maintenance because you sometimes have to reconstruct the whole thing, versus lower infiltration rate, but low maintenance. And actually kind of like those discussions because it's like, yeah, what do you want? But yeah, I'm sad to hear that there isn't the data about that yet because it's only 2 locations I researched.
No, I mean, look, I obviously I've done it, so I can't comment too much on other than the fact that with our dusty atmosphere, I'm sure they would clog very quickly, and we don't have the equipment, and we're not going to get the equipment. So, but again, it comes down to what works for you. I mean, as I said, walking back in Delft, and what would I do in Delft?
Yeah.
I can think of alternatives to permeable paving in Delft. So I guess one doesn't have to do permeable paving.
Have you also been working on like these kind of how do you say it, flow charts, like for which one you can choose? Because now in our municipality we're trying to do that, like which infiltration system do we choose considering the location? And that's you've already showed in the study that that's the key. It's quite new here, but we are thinking about it like, okay, not every street is the same. No, of course not. In a big city, in a small village, in another country, but we're trying to make some kind of decision flow tree, in order to choose that, because now it's usually just expert judgment or people like you that put some research together that are the things we go on. So I was wondering if you have been working on a more overall decision tree for those kind of things, because I hear you talking about the decision trees.
No, I mean, it's a good point. Maybe I should.
If you still have time, of course. Yeah.
or do you want to employ me? So it's
would be nice,
my observation. Okay, so this is an observation working for 15 or so years, I guess. No, longer than that now, isn't it? Nearly 20 years, I guess, on SUDS, as to kind of what works. And I mean, the things that work the best are the natural systems, aren't they?
Yeah.
Surprise, surprise. So as you hear already, I'm a great fan of bioretention. Why am I a great fan of bioretention? Because anyone can do it. I mean, maybe they don't do it because the engineers are scared that they'll be made redundant by the landscape architects. But in any case, anyone can do it. It can be done just about anywhere. And the main thing is really about getting your levels correct. But here's the important thing now. So the system works well for 2 reasons. One is that it is vegetated. And why is vegetation important? Because it keeps those macro pores open. Yeah. And the second thing, which is important, particularly in a South African situation where, I mean, at the moment it's mosquito season, right? So they're kind of driving us crazy. My wife and I have to have a fan blowing full blast on us to blow the mosquitoes away. You don't want standing water, but it also turns out that if you let it, you want to alternate wet and dry cycles. You want your thing to dry out. In South African terms, of course, it will dry out, even get a bit of dust. That's okay. You can tolerate that in the bioretention. And then when it rains again, you'll get good infiltration. But before it clogs, it dries out again.
Hmm.
You know, you get this cycle, and there's a name. They use it also, by the way, for a low-cost treatment of sewage as well. Just can't remember the term, but this alternate wetting, drying, wetting, drying, wetting, drying helps to maintain the surface infiltration. It really does. And if the key thing is that ideally you don't want standing water for longer than 24 hours, because you don't want to provide a place for the mosquitoes to get a foothold. So you want to keep that going. Now, the vegetation thing, of course, you need the right vegetation, but there's a wide variety of vegetation you can choose from. And now the maintenance is the kind of maintenance that any gardener can do. South African context, we have got millions of unemployed people who would be very happy to go and with shears and trim some bushes by the side of a road for a small amount of money, but whatever. I've heard the same thing said when Bill Hunt was talking about maintenance in the USA. It's everybody can trim bushes, everybody can mow a lawn, everybody can do this. That's the kind of maintenance that you want. The problem is that fine, you can have a fancy vacuum that will take the dirt out of your porous bricks, but that's expensive.
Yeah.
Yeah.
And it needs skills and materials and everything. So it's it's really good. I think we should round up. This is already the longest episode of Green Blue. So there's a compliment to you, Neil. Absolutely.
I'm happy to talk about these things, and I'm happy to talk about some of my other passions. If you're ever interested, I said, if you really want to hear about the investigation we did, a nutrient movement PICP, I can talk about that, or I can talk about some of this other stuff that we're doing at the moment. All good.
Yeah, we really
We'll
should.
get back on that. Yeah,
absolutely. And also the grass, the grid grass-filled pavers. That would be very interesting because it doesn't have to be grass. We also have other like sedum, which is drought resistant. But there's a lot of thing in my head. We'll get back to you, Neil.
another time.
To that. Yeah, exactly.
One thing that you like is managed aquifer recharge of stormwater in a low-income area. That's my current project.
All right. So we give you a couple of weeks and you can get all the information going, and then we ask you again. Now, thanks a lot.
Is that on the Cape Flats aquifer?
Yes.
Cape Flats, is it? Okay,
yes.
Cool. I was also looking into that very recently.
Yes.
I still have a lot of questions for you, so I think I'm going to have to email you.
Yeah, absolutely.
We're maybe round up for now.
Exactly. Yeah. And Charnay, you set this up, so thanks to you.
Thank you.
While was the recording, so and Liliana said she loved your presentation as well. She had to leave, so that's good. So what we're gonna do next week, Sydney? Marianne Langevoort.
Next week is it Marianne Langevoort from Touw, right?
Yep.
She's going to talk about the water quality from infiltration, suds again, but mainly on the greener parts, and then I'm not sure what the English words are. Growing concern substances,
So basically microplastics.
Microplastics, and but I think she also will talk about PFAS a little bit. At least I hope so, because I already talked with her about that, and she had some interesting views on that as well. So hopefully we hear about all of that next week.
So more happy stories. All right.
Okay,
Neil,
great.
thanks again.
Thank you.
Yes.
Yeah.
Thank you very much.
Thank you.
Bye, Neil.
Hopefully see you next week.
Tot ziens.
Thank you.
Bye.
Now.